Okay, so we're given a point Q, 113, and the line R, and we define the shortest distance. So let's draw this. So let's say I have my point Q here, and the line L. So my shortest distance is always going to be the perpendicular distance. Right? This is because if we have a line here, then this will become the hypotenuse of the triangle. So we know that this is always going to be larger. So there are many ways to solve this question, but one way is to use vector projections. So let's label this point here as A. So we know that the line has a direction of 2, 3, 1. This is given in the question. So if we project AQ onto the line, we're going to get this. But if we project AQ onto the perpendicular of the line, we're going to get this, the green line. So in other words, the green line is going to be the answer we're looking for. So let's label our green line as, well, D. So how do we find D? So from our previous video, we went through the formula for projection. What we're going to see is that D is equal to the magnitude of the cross product of A and B over the magnitude of B. So in order to use this formula, what we're going to need is to find the vector A. So our B is given by the direction vector 2, 3, 1. So what we're going to need to find is the vector A, which in our question is going to be the vector A to Q. And to find A to Q, we're going to need a coordinate for A. And A can be any point on the line. And the reason is that, let's say A is here. AQ is always going to go up by a distance of D. So it doesn't matter where my A is, because my Q stays the same. So AQ, or A, can be any point on the line. So we can use 1, negative 1, 2. So that means AQ is going to be 1, 1, 3 minus A. We're going to use 1, negative 1, 2, which is given by our equation. And we're going to get 0, negative 2, and 1. So now we know what AQ is. We can use the formula. Our distance D is going to be equals to A, which is AQ. So it'll be 0, negative 2, 1 cross B, which is our direction vector, 2, 3, 1. And that's over the magnitude of our direction vector, 2, 3, 1. So now we can find our cross product, which is going to be negative 1, 2, negative 4. At the bottom, it will be the magnitude of 2, 3, 1. So now we can rewrite this as the square root of 1 squared plus 2 squared plus 4 squared over the square root of 2 squared plus 3 squared plus 1 squared. And if we put this in the calculator, our answer is going to be root 6 over 2.